All right, section 6.2 talks about confidence intervals for the mean when the population standard deviation is unknown. So again, guys, I just want to kind of go over something real quick. Remember, this is my population standard deviation, all right? So in 6.2, we're not going to know the population standard deviation. So it says, in the previous section, we learned how to construct confidence intervals for the population mean using the standard normal distribution when the population standard deviation was known. When the population standard deviation is not known, we're going to use the sample standard deviation in something called the t-distribution to construct confidence intervals in a similar manner for the population mean, but only when the random variable is approximately normally distributed. All right, so it says if the distribution of a random variable x is approximately normal, then the t value is going to be equal to the x bar minus my mu divided by s divided by the square root of n, where s represents my sample standard deviation, okay? This follows a t-distribution. Critical values of t are denoted by tc, where c represents the level of confidence. Excuse me, it says it may help to think of the t-value kind of like a z-score that we've computed in the past. The formulas are going to be similar, all right? So, properties of the t-distribution. The mean, median, and mode of the t-distribution are equal to 0. The t-distribution is bell-shaped about and symmetric about the mean. The total area under the curve, under a t-curve, is 1 or 100%. The tails in the distribution are thicker than those in the standard normal distribution. The standard deviation of the t-distribution varies with the sample size, but it is greater than 1. The t-distribution is a family of curves, each determined by a parameter called degrees of freedom. The degrees of freedom are the number of free choices left after a sample statistic such as x bar is calculated. When you use a t-distribution to estimate the population mean, the degrees of freedom are equal to 1 less than the sample size. So this piece right here is going to be super important, okay? And it says, as the degrees of freedom increase, the t-distribution approaches the normal distribution. And after 30 degrees of freedom, a t-distribution is very close to a normal z-distribution. All right, and it says, typically a t-distribution table is used to find the critical values of t, much like the normal distribution is used to find the values of z. All right. So the first thing I have here is the degrees of freedom concept. And it says, suppose there's an equal number of chairs in a classroom as there are students, 25 chairs and 25 students. Each of the 24 students to enter the classroom has a choice to which chair he or she will sit in. There is no freedom of choice, however, for the 25th student. Okay, so let's kind of do that same idea, but instead of doing 25, let's just do 5, okay? So we have 5 chairs, right? And we have 5 people, A, B, C, D, and E, okay? So when person A is going to go, they actually have 1, 2, 3, 4. They have choices, right? So suppose, I'm going to make this up. Suppose A goes here, all right? Now B is going to go next. B can go anywhere they want. Suppose B decides to sit over here. Same thing with C. C has choices. C can decide, suppose C decides to sit there, and then D is going to come up next, and suppose D decides, you know what, I'm going to sit over here. You know who doesn't have a choice? This one. Person E has no choice because there's only 1 seat left, okay? That's what we mean by degrees of freedom, okay? So the first problem here says, find the critical value TC for 90% confidence level when the sample size is 22. Okay, so we're going to look for our T90 when my N value is 22. Well, if my N value is 22, then my degrees freedom is going to be 22 minus 1, which will be 21. Okay, so there's a couple things I need to know. Number one, we're going to use a 90% confidence interval, and my degrees freedom is going to be 21. So guys, when we have our table, one of the, in that handout that I gave you guys that had the table with the z values, so this is what it looked like. If you scroll down past these here, here's my t distribution, okay? So the first thing I want to mention is we're looking for 90% confidence level, right? And we're also looking for degrees of freedom. We said was going to be 21. So what I'm going to do is go here and here. So I want you to look at my confidence interval right here. It's going to look like this, and we're going to have two t values. One will be negative, one will be positive. The positive value is 1.721, okay? So let me bring up my notes again here. So I'm going to have something that's going to look like this. This is going to be 0.90, my negative TC and my positive TC. So let me just kind of scroll over a little bit to the right. Okay. All right, 0.90. And the value we came up with was, I want to say it was 1.721, that one right there. So this is a negative 1.721, and this is a positive 1.721, okay? All right, so number 2, it says find the critical value TC for 95% confidence interval when the sample size is 12. All right, so I'm going to look for my T at 95% confidence. My sample size I know is 12. That means my degrees freedom is going to be 12 minus 1. It's always going to be the sample size minus 1, which will be 11. Okay? So 0.95. So I'm going to look for 95% confidence level with a degrees freedom of 11. Come back to my chart here. So here's 95% confidence level. Here is my degrees freedom of 11. So the value that we're coming up with is 2.201. So this is a negative 2.201, and this is a positive 2.201, okay? All right. So now in the next part, we have something called confidence intervals and t distributions. Okay, so it says, to construct a confidence interval for the population mean mu, so again, guys, just a quick reminder, this is my population mean. When I don't know my population standard deviation, the margin of error E is calculated using the sample standard deviation S and the critical value TC. Okay, so just another reminder, this is my sample standard deviation, okay? All right, so here is my formula. It says E equals TC times S divided by the square root of N, all right? So let's see if we can figure out this problem. It says you randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 with a sample standard deviation of 10 degrees. Construct a 95% confidence interval for the population mean temperature of the coffee sold. Assume the temperatures are normally distributed. All right. So let's take a look here. First thing we're going to do, we know that our X bar is 162 degrees. And we know that our sample standard deviation, because it tells me right here, is equal to 10 degrees, right? So the first thing we want to do is we want to find the error, okay? So to find the error, I'm going to use this formula right here. We're going to go TC times S divided by the square root of N, okay? Let's see, what else do we know? We know N. N in this case was 16, right? So if N is 16, remember my degrees freedom is going to be 16 minus 1, which will be 15. Okay. All right, so the first thing we're going to do, we're going to find our TC value. Okay. We're going to go to 95% confidence with a degrees freedom of 15. So 95% confidence with a degrees freedom of 15, I am coming up with, let's see, yes, 2.131. Okay. So my TC is 2.131. All right, so now let's see if we can find this. We're going to take 2.131 times my sample standard deviation, which was 10, divided by the square root of my n, which was 16. Okay, so let me do this on my calculator, turn it on, clear it out. Okay, 2.131 times 10 equals divided by the square root of 16, close off my parentheses, and I'm coming up with this 5.32. I guess I'll go to like 3 decimal places. 5.38, 5.328. I'm sorry, 5.328. Okay, so here is my error, right? Okay, so now I'm going to draw a picture. Okay, so on up here, the t-value, this was a negative 2.131, this was a positive 2.131, 95% confidence interval. Okay, so now if we're going to find our confidence interval, the way we're going to do this, guys, we're going to take x bar minus e and x bar plus e. So our x bar in this case, I want to say, let me scroll back, I think it was 162. Yes, 162. So 162 minus 5.328, and then 162 plus 5.328. Okay, so let's do that. 162 minus 5.328. That's given me 156.67. 156.67. And we can do this again, but just change that minus to a plus. There we go. 167.33. 167.33. And here is my confidence interval, right? Okay, so let me scroll back over here. All right. All right, so taking a look at number 4, it says we randomly select 20 cards of the same model. Okay, so what that's telling me, number 1, my n is going to be 20. So guys, if my n is 20, my degrees freedom, remember it's always going to be n minus 1, will be 19. Okay. So we randomly select 20 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean, so my x bar is 9.75 days, okay? With a sample standard deviation, my S value is going to be 2.39 days, okay? Construct 90% and 95% confidence intervals for the population mean, the number of days a car model sits on the dealership's lot. Compare the widths of the confidence intervals and assume the days on the lot are normally distributed. Okay, so the first thing we're going to do this with a 90% confidence interval. Okay, so we're going to do this with a 90% confidence interval. We're going to find our TC values. Okay, so remember, one of them is going to be negative, one's going to be positive. Okay, so I'm going to come back to my chart here. We're looking for 90% with a degrees freedom of 19. Okay, so here's 90%. Degrees freedom of 19, I'm coming up with 1.729. Okay, so this one here is a negative 1.729. This is a positive 1.729. Okay, so we found our TC value. TC is 1.729. Now remember, to find the error, I'm going to take that value TC, I'm going to multiply it by S divided by the square root of n. This is going to give me the error, okay? So here's my TC value, 1.729. times my sample standard deviation, which is 2.39 days, divided by the square root of n, and we said was the number 20. Okay. So let me grab my calculator again. Let me turn it back on, clear it out. So 1.729 times 2.39, okay, divided by second square root of the number 20. Close off my parentheses. And I'm coming up with 0.924. 0.924. Okay, so here's my error. All right. So what I'm going to do now is to find my confidence interval. Remember, my confidence interval is going to be x bar minus the error and x bar plus the error, right? So my x bar, we already said, was 9.75 minus 0.924, and then 9.75 plus 0.924. Okay. So let's go 9.75 minus 0.924. So the first value that I'm coming up with is 8.826, 8.8, let's go 8.83. And then we can do this again, but change the minus to a plus. And 10.67. Okay. So we found our confidence interval, right? We got our confidence interval. All right, so now we're going to do the same thing, but we're going to do it for 95%, okay? So I'm just going to take my notes. I'm going to move them over to the right a little bit over here. Okay. All right, so my n was still 20. My degrees freedom was still 19. My x bar was still 9.75. My sample standard deviation was still 2.39. And what we need to do now, we need to find those TC values, right? One of them's negative, one's positive. So now we're looking at 95% confidence interval with a degrees freedom of 19. So I'm going to go right here. Here's 95% confidence interval. Here is my degrees freedom of 19. And I'm coming up with 2.093. Okay. Negative 2.093, positive 2.093. All right, so let's find our error. So remember, the error is going to be the TC value times S divided by the square root of n. So 2.093 times 2.39 divided by the square root of 20. So let me get my calculator. Let me clear this out. 2.093 times 2.39 divided by the square root of 20. Okay. And now I'm coming up with bigger error, aren't we? 1.1, I'll go 1.12. Okay. So now remember, I'm going to take my x bar, which was 9.75 minus 1.12, 9.75 plus 1.12. Here we go. All right, 9.75 minus 1.12. So 8.63. And second entry, change that minus to a plus. Enter 10.87. Okay, so it wants us to do a little comparison between the two, right? Let's see. Compare the widths of the confidence intervals, okay? So I want you to think about those confidence intervals for a little bit. Let me kind of come back here. I know I should have probably given you guys some more room. Sorry about that, guys. But I want you to look at the two confidence intervals we have, okay? So if I were to draw, say, my number line here, right? And I don't know, say here's 7, here's 11, and say here is 8 and 9 and 10. Okay, so let's do the two confidential. 8.83. 8.83 would be from about right here. 10.67 would be right about there, right? So actually I'll do those in black because those were the numbers that we had written here in black, right? There's about 8.83, 8.83, 10.67. Now, when I look at the intervals here, and I'll actually do these in green, 8.63. 8.63 is going to be more to the left, right? And 10.87 will be more to the right. So the bigger my confidence level, the bigger my interval is going to be, okay? That's sort of the point here. All right. So now, it says, use the given confidence interval to find the margin of error and the sample mean. Okay, so we did a problem like this back in 6.1. So I want you to think about what we have here. Here I have 12.4, and here I have 21.4, and I'm looking for my X bar, right? It's going to be in the middle. So remember what we're going to do. We're going to take these two numbers here, and we're going to add them together and divide by 2. So let me take my calculator. I'm going to take 12.4 plus 21.4, add them together and divide by 2, and I'm coming up with 16.9. That is our number right here. Okay, so we know our X bar, 16.9. Now, the other thing we want to do, we want to find our error. Okay, so if we're going to find our error, we're looking for the distance between here. So I can take my calculator, 21.4 minus 16.9, and I'm coming up with 4.5, right? Guys, that would also be 4.5, okay? Regardless of how you do it, you're going to come up with the same thing. All right. So the next part here says, so how do we know if we're going to use the the standard normal distribution or the t-distribution, okay? If we know the population standard deviation, we're going to go ahead and go with our normal curve, right? And using the z table. If we don't know the population standard deviation, then we should be given the sample standard deviation, and we're going to use the t-table, okay? So let's take a look here at number 5, and it says you randomly select 25 newly constructed homes. All right, so what does that tell me? N is 25. The sample mean construction cost is $181,000, so my X bar is $181,000 with a population standard deviation of 28. This is my population standard deviation of 28,000, okay? Assuming construction costs are normally distributed, should we use the normal distribution, the t-distribution, or neither to construct a 95% confidence interval? We're going to use the normal distribution. Why? Because we are given the population standard deviation, okay? So let's go ahead and do that. So guys, in order for me to do this, right, I'm going to be using my z table, okay? And this is how I'm going to find my my error. So the first thing I'm going to do, I'm going to look for, what's our 95% confidence? Okay, so remember what that means. That means that the area here under the curve is 0.95, right? So if the area underneath the curve is 0.95, that means that I have 5% left for those two spots, right? So 5% is 0.05. I'm going to divide that by 2. That's going to be 0.025. That's telling me that the area to the left here is 0.025, okay? So remember how I'm going to find my z value. I'm going to come back to my calculator, right? Oops, clear it out. I'm going to go second vars. I'm going to go to inverse norm. Oops, inverse norm. Hit enter, and I'm going to type in 0.025. Close it off. So the z value that I'm getting is negative 1.96. So this value right here, negative 1.96. So this is going to be positive 1.96, right? That's my critical value. That's my ZC. Okay, so 1.96, okay, times sigma, which we said was 28,000, divided by the square root of n we said was 25. Okay, so let me do this on my calculator. So let me clear this out. We're going to go 1.96 times 28,000 divided by the square root of 25 equals, and I'm coming up with 10,976. 10,976. So now, if I'm going to find my error, my interval, I'm sorry. Remember how I'm going to do my interval? It's going to look like this. X bar minus the error, X bar plus the error, right? So, move this over a little bit. Okay. So our X bar was 181,000. So 181 minus 10,976, and then 181 plus 10,976, right? So let's go 181 minus 10,976, okay? So the first number I'm coming up with is 170,024. And the second one, let's come back here, change that minus to a plus, and enter, is 191,976. 191,976. Boom. And here is my confidence interval, okay? All right. Now let's come back to problem number 6. Okay, problem number 6 says you randomly select 18 adult male athletes and measure the resting heart rate of each. The sample mean heart rate is 64 beats per minute with a sample standard deviation of 2.5 beats a minute. Assuming heart rates are normally distributed, should you use the normal distribution, the t distribution, or neither? Okay, so let's go through the problem. First thing we know, N is going to be 18, right? We're picking 18 adult male athletes. We know that the sample heart mean, so we know that my X bar is going to be 64 beats per minute, right? We know that our sample standard deviation is 2.5 beats per minute, okay? So should we use normal distribution or t distribution? We're going to use t distribution because we have the sample standard deviation, okay? So guys, remember, if my n is 18, my degrees freedom is going to be 18 minus 1, which is going to be 17, okay? The way I'm going to find my error is we're going to take TC times my sample standard deviation divided by the square root of n, okay? So the first thing we're going to do here, we're looking for a 90% confidence interval with the degrees freedom of 17. So let me come back to my table. We're going to go 90% confidence interval with the degrees freedom, what was it again? Degrees freedom of 17, right? Okay, so degrees freedom of 17, 90% confidence interval. I'm coming up with 1.714. Okay. All right, so my TC value is 1.714. Right, that was the right number. 90%. What was it? Degrees freedom. I think it was 17. Yes, just making sure I write the right number, guys. Degrees freedom 17. 1.740. Sorry. 1.740. There we go. All right. So let's see if we can find that error. So I'm going to take 1.740 times my S, which is 2.5, divided by the square root of 18. Okay. So take my calculator, let me move it over here, clear it out. 1.740 times 2.5 equals divided by the square root of 18. Close that off, hit enter, and I'm coming up with 1.03. Okay, 1.03. So now, if I'm going to find my error, I'm going to take my interval, x bar minus the error, and x bar plus the error. So my x bar was 64 minus 1.03, 64, plus 1.03. So let's take our calculator and let's do that. 64 minus 1.03, 62.97, and the other part, change the minus to a plus, 65.03. Okay, so 62.97 to 65.03 would be my confidence interval. All right, so for this problem here, guys, I'm going to show you all. I'm going to do this one on the app just so you can see how it works. So I will upload that one and attach it to this part here. All right, so guys, to do this next problem here, it says the SAT scores of 12 randomly selected high school seniors is shown. Find the sample mean, sample standard deviation, and construct a 99% confidence interval for the population mean. Assume the population is normally distributed. So I'm going to show you all how to do this on the calculator using the calculator app, okay? All right, so the first thing I need to do is I'm going to take these numbers here, and I'm going to enter them in on my calculator, okay? So I'm going to use my list. So let me get my calculator. Here we go. Okay, so just so that you can kind of see what I'm doing here. Okay, clear. All right, so guys, I'm going to go to Stat. I'm going to go to Edit. You can see my list is clear. I'm going to start entering my numbers. 1700 is the first one, enter. 1940 is the second one, enter. 1510, enter. 2000, enter. 1430, enter. 1870, enter. I have this on my computer here at home, guys, so I can see my screen on my laptop, and that's what I'm using. 1650, enter. 1820, enter. 1670, enter. 2210, enter, and 1380, enter. Okay, so look, we got all our information there, right? So again, just to double check, all I did is enter in those numbers right there. Okay, look what we're trying to find. We want to find sample mean, sample standard deviation. So we're looking for two things, looking for x bar, and we're looking for the s. Okay, so I'm going to come back here. I'm just going to go Stat again. I'm going to calculate my one variable stats. Which list are we looking at? We're looking at list 1. Close it off. Okay, my x bar tells me it is 1764. I'm just going to go to one decimal place, 0.2. 1764.2. So this is 1764.2. Now the next thing I need to find my sample standard deviation. Sample standard deviation, guys, it's going to be the fourth one down. Do you see where it says SX? That S is telling me that's my sample standard deviation. So that's 252.4. Okay, so 252.4. And again, just so you know where I'm coming from, I'm looking at the one that has the letter S. So it's the fourth one down. Okay. All right. So now the next thing we're going to do, we are going to go to, I'm going to do this the same way that I have here. I'm going to do this the same way on my app. Okay. So I'm going to go back to my stat button. I'm going to go to test, and then I'm going to select T interval. Okay. And remember, we're looking for a 99% confidence interval. Okay. So my confidence interval is going to be 99%, which is the same thing as 0.99. Okay. So let me come back here. Let me go to stat. I'm going to go to tests, and I'm going to go to T interval. Okay. So I want you to notice something. couple of things that it's telling me already is it is telling me that my X bar is the 1764.1, all that stuff. There is my SX. It's the 252.3035. I think we had 4. N is 12 because we know we had that there. The only thing that you may have to change, guys, in my case, it's already here, but I'm going to make this up. Suppose you had 0.90, right? Suppose that's what you had. Then what you would have to do is you'd have to go right here, type in 0.99. Notice on my lower and upper, nothing has changed. The way it'll change, move your arrow. Move it up, move it down, whatever. And now look, it's giving me my lower and my upper limit. So my lower is 1537.9. So 1537.9, comma, and my upper is 1990.4. Oops. 1990.4. 0.4, not comma. And here's my confidence.